this first lesson, which focuses on graphing, we'll be using a technique that we learned in the last lesson, which is to create a table in order to graph a linear equation. On your paper, you'll see that we have a definition of the word linear. Please notice that I'm pronouncing the word linear, not linear. It's really tempting to say the word line, because after all, the first 4 letters of this word do spell line. And that's a great way for us to remember what linear means. Linear means a straight line, but it's pronounced linear, not linear. So go ahead and note down the definition here that linear means that we're getting a straight line as our graph. So nonlinear would be the opposite or the antonym, and nonlinear would be any graph that is not a straight line. And the way that we can tell if a graph is nonlinear is if there is an exponent that is greater than 1. If the exponent on the variable is greater than 1, then the graph will not be linear. For example, here is x to the 2nd power. 2 is greater than 1. That means this is not a linear graph. Y equals x to the 3rd minus 19. That exponent is 3. That's greater than 1. That's not going to be linear. So these equations will make graphs. They just won't be straight lines. They are non-linear. And we're going to talk quickly about horizontal and vertical lines. Horizontal lines are written y equals, and then there's a number there. There's no x in it. It's just y equals 5 or y equals -3. So your definition there for a horizontal line is written y equals any number. And here's what this would look like. On my graph, let's see if I can move this. All right, on my graph, I'm going to take my pen and I'm going to go to the place where y equals 5. This is the y-axis. It's the up and down axis. So I'm going to go up to 1, 2, 3, 4, 5. Here is the number y equals 5. This point is actually the point 0, 5. But this isn't the only place on this graph where y equals 5. What about this point all the way over here? How would I get to this point? Well, 1, 2, 3, 4, 5, 6, 7, 8. I moved 8 to the right, and then I went up 5. Y equals 5 here as well. Y equals 5 here, y equals 5 here, y equals 5 here. And hopefully you can see that this is forming a straight line. So if I were to put a line through these points, this is what it would look like. And I'll go ahead and put an arrowhead at this other end as well. This is the graph of y equals 5. It created a horizontal line. The second list there that says y equals -3, I'm going to do that in the same way. I'm going to go to the place on the graph where y equals -3. So I begin at the origin, and I move down 1, 2, 3. Here's the point y equals -3. Actually, all of these points going across have y is -3. So I'm going to make another horizontal line because that's what the equation was. And I'm going to put arrowheads on both sides showing that this line continues forever in both directions. Every single point on this graph has a y value of -3. This point right here is 1, 2, 3, -3. This point over here is 1, 2, 3, 4, 5, 6. It is -6. I went 6 to the left. and then down 3. Every point on this line has a y value of negative 3. So the vertical line is going to be really similar. The vertical line is written x equals any number, like x is 5 or x is negative 3. So what you'll notice is this is almost identical to what we just wrote down, except instead of a y that we had before, now it says x. So I'm going to figure out how to graph this line by going to the place on the graph where x equals 5. This is the x-axis. So I'm going to move x equals 5, 5 to the right. 1, 2, 3, 4, 5. X equals 5. But this isn't the only place on the graph that has x equals 5. This is the point 5, 0. But this point right here, that's the point 5, how much did I go up? 1, 2, 3, 4, 5. That's the point 5, 5. And if I went all the way up here, that's the point 5, 10. The same is true if I went right here. This point is 5, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. This is negative 5, negative 6. And what I am forming is a straight, so it's linear. This is a linear graph, and it is vertical. And I'll do the graph of x equals negative 3 in the same way. So I'm going to first go to, on the graph, my origin, and I'm going to go left 1, 2, 3. This is the point negative 3, 0. But that's not the only place on the graph where there is x equals negative 3. This is negative 3, 2, negative 3, 4, negative 3, 6. If I jump down here, now I've got negative 3, negative 3, negative 3, negative 4, negative 3, negative 5. Every single point on this straight, linear, vertical graph is x equals negative 3. So those are our two special graphs, the horizontal line and the vertical line. But the majority of graphs that we will have that are linear will be slanted. So they'll either be gradually going up or gradually going down, but they won't be vertical or horizontal. This is the most common type of graph. And what we're going to do to graph these type of graphs that look like this, y equals 3x plus 2, we need to get the y by itself, which in this example, the y is already by itself, but that's going to be important in later lessons, so we're going to write it down. Once the y is by itself, we're going to make a table, and you guys have already seen this input-output table in a previous lesson. So I'm going to take my equation, oops, can't take my equation, I'll write my equation. Right here in the middle, my equation is y equals 3x plus 2. And I've asked you to use the values negative 1, 0, and 1. And the reason I've chosen those numbers is so that we've used 1 positive, 1 negative, and we've also used 0. And since you've seen this table before, you know how I'm going to proceed to fill in this table. I'm going to write y equals 3 bubble plus 2. And I'm going to go ahead and I'm going to write all of those first. And remember, when I say bubble, what I'm actually saying is open set of parentheses. And I'm just going to write that same thing 3 times, because I know I'm going to use that 3 times. And now I'm ready to go back and fill in a negative 1, and I'm ready to fill in a 0, and I'm ready to fill in a 1. 3 times negative 1 is negative 3. and I bring down that plus 2. And negative 3 plus 2, different signs, so we subtract. That's going to be 1, and it's negative. So that's kind of cool. I plugged in a negative 1, and I got out a negative 1. On to my next point. 3 times 0 is 0, plus 2. 0 plus 2 is 2. I plugged in a 0. I got out a 2. 3 times 1 is 3, plus 2 is 5. I plugged in a 1, and I got out a 5. And in our last lesson, we learned how to take this table and turn it into ordered pairs. And ordered pairs are what we need to graph. I have found 3 points. I have found the points -1, -1. That's right here. The next point I found was 0, 2. And the final point that I found was 1, 5. These 3 ordered pairs give me enough to be able to graph my straight line. I'll begin here, -1, -1. Start at the origin, left 1, down 1. Next point, start at the origin. It says 0, 2. That means I don't move horizontally, but I do move up 2. And the final point, 1, 5, I begin at the origin. I move 1 to the right, and I move up 5. And from those 3 points, I'm actually able to create a straight line that will go through those 3 points. See, that line doesn't work very well. I'll draw one by hand. It won't be that straight, but I'll be able to get it closer to those points. Your graph should go right through those points. See if I can move this to get it up just a little bit closer to those dots, just like that. You can see that my line has arrows at both ends, which reminds us that this line continues in both directions forever.